Hi all, welcome to the first part of the video lecture on database management systems. So database management systems, or in short DBMS, is the course that is introduced. So we are studying the 2019 scheme KTU syllabus for this one. Okay, so let's see the syllabus first and what are all the contents. So this is the course CST 204 is the course code, database management system, introduced in the year 2019 by KTU. So it's a 4 credit course, so you know its importance. Okay, so it's a very core subject, and if you are looking at any competitive exams like gate exam and all, so there will be considerable weightage for this subject. Like you can expect some 8 to 10 marks on an average from this subject. So take that seriousness when you are studying this course. Okay, so there is no prerequisite actually. So this is a fundamental paper, and this itself acts as prerequisite for many subsequent courses that you will be studying in your higher semesters. Yeah. So if you are looking at the course outcome, so these are all the course outcomes given. Course outcome 1, that is summarize and exemplify the fundamental nature and characteristics of the database system. So this is basically about the understanding. Okay, so so CO1 covers the fundamentals. So just you should be able to summarize the basic concepts and some examples of the same, like that. So it's on understanding level only. So now if you're looking at CO2, model real world scenarios given as informal description using entity relationship diagram, ER diagram. So that is another. After covering fundamentals, we will move on to this ER diagram and we will see what it is. It's basically a conceptual design where this real world scenario will be captured using a model. Okay, so we will see that's a very simple and easy to understand concept, and it is under apply level. So they can ask you like design something, ER diagram for a real world scenarios. That kind of questions you can expect from this. Okay, now once you do this ER diagram, in this particular modeling, then we will go for a model called relational model. So what is this difference? It's like a ER model is something that is very much closer to the user. Okay, so from the user we will collect the requirement, what kind of data storage is needed, what kind of operations, and right all together. So we will design what kind of DBMS software to be used, and for that the one which is interacting directly with the user is the CR diagram. Okay, so that will just take the requirement specification from the user and it will model. Okay, now it will be given to the design, and now this relational model is something that is very closer to the implementation. So once you map the CR model to relational model, you can directly go for the implementation. So like that. Okay, that is the peripherally at this point I can say the difference between ER and relational model, and we will see more about it when we are going through the subject. Okay, and that also it's in the analysis level. So that ER model you are supposed to analyze and you have to map it to the relational model, and that is something closer to the implementation. So it's very important topic. Okay, so it's going to the next level. So that kind of questions also you can expect from this. Now demonstrate the features of indexing and hashing in database applications. So indexing and hashing, of course, they are used for making the searching process in a database easier, right? And again we will see this in detail in our subsequent modules, and it's come under the apply level. And discuss and compare the aspects of the concurrency, control, and recovery in database systems. So when you implement this database in a large scale application, so where this transactions everything involved, and that time this concurrency, control, recovery, those things will come into play, and we will get a feel about it, how these things are working. Okay, now this is something that they introduced in 2019 scheme, and if you're looking at 2015 KTU syllabus, this topic was not there. So it's about something called NoSQL. Okay, so we can call it not only SQL, something like that. So SQL is the query language that we are studying mainly. Okay, now when you are moving on to NoSQL, means it is something beyond this SQL. So it's a model that is not this RDBMS model. Okay, anyway we will see that. So it's something the recent trend, so that is why it is being introduced. Yeah, that about it. Now this here you can see the COPO mapping and other things. Okay, anyway the type, what the type of questions we are supposed to ask from this remember, understand, and apply level, those mark distribution, those things are given. Now we have that 50 mark internal evaluation and 100 mark you have to secure from the university exam. Attendance, there will be 10 marks, so that will be taken in for our online as well as offline classes. And continuous assessment, 25 marks for both internal exam, so covering to 2.5 module each. Okay, so that is the expectation. Then continuous assessment through assignment and other works, that is for 15 marks. Yeah, that about it, and these things are something common for all courses. Now if you are looking at the first module, you can see the first half is basically about the concept and overview of the database management system, the basic understanding terminologies, those things we are will be getting from this first half of the module 1. Characteristics of the database system, database users, different types of users, and small questions they can frame from that, and different types of data like structured, semi-structured, and unstructured data, data models, and schema. And accordingly, a small concept called 3 schema architecture, database language like data definition and manipulation languages, database architecture, and classification. So this is very simple one. Even though I'm not taking class on it, you can easily understand it by reading textbook and all, so there is nothing tough in it. Okay, anyway, I will try to cover this also, but the main focus of this first module is this model, that is of importance. Okay, so if you are looking at any further exams and all beyond this your course, so that time you will definitely, what I mean is specifically about that gate exam diagram, there will be considerable number of questions. Okay. Yes. After covering model, where we will see what is entity, relations, attributes, different types of relationships, many things. Okay, then we will move on to module 2, where we will discuss mainly that relational model. So the basic constraints, integrity constraint of this model, and how to map that diagram to relational model. That mapping is important. Then relational algebra we will see, and then we will move on to that SQL, structured query language, and how the basic operations can be done in it, in syntax and all. Then in the third module will be seeing data manipulation language part. So this second module, we are in SQL itself, we are considering that create, drop, and alter. I mean the structure as a whole, how we are creating. Manipulation means once you create the structure and the database structure, how we can manipulate the data over it. So what about the SQL queries on single and multiple table and nested query? So query is basically how we can access information from a given database. The user will be having some set of requirement, right? So what kind of data he is in need of it, and accordingly we'll be knowing how to write the queries, right? How to take such subset of information from a stored huge collection of data. And there is something called the views, assertion triggers, those things we will see. And in the second half of that third module 3 is basically about that indexing and all, like the physical data organization and concept of records, blocking factor, and those things. So they are all also, so we are just trying to get a feel about the hard disk, how this information, the huge data is being stored in your hard disk, right? So how they are organized. So basically we are using two structures called B tree and B plus tree. I don't know whether you studied this in your data structure course or not. Anyway, B tree, B plus tree, you can see it's somewhat an extension of the binary search tree concept that you studied for sure. And B tree and B plus tree also you may study it, or we will study here. Okay, so how we will access information and store them with using this structure, and how they are making the process of retrieving the data in an efficient way. So those things we will see. Now in the fourth module is another very important concept, so regarding gate exam and all, so definitely questions will be there from normalization. So this is a way of filtering the database to the towards a most efficient kind of representation. So from the original representation, many redundant data, everything we will eliminate, and we will filter it, and we will come up with a very precise form, so that implementation of the actual database over that relation model will be efficient. So different standard or canonical or normal forms we will study. So before covering normal form, we will see something called the functional dependencies. There are different actions, some closure property, and this covering and all, minimal cover, those things. So these are all some for theoretical interest, and then not only theoretical interest, in your organization also you are supposed to do this normalization. So once you know the theory, then only you can apply it. So after doing normalization only you can go for the actual implementation. Okay, normalization of the relational model. So different normal form we will study, like 1NF, 2NF, 3NF, Then there is something called a BCN, a boycott normal form, and how we can do this decomposition in a lossless and dependency preserving way, and how to check it. Okay, so these are all very important concepts from this. And there is for fourth and fifth normal form also, but anyway, those things in most of the organization we will go up to 3NF or BCNF, so it's enough. So that's why I think in the 2015 scheme that 4 and 5NF were also there, but now they eliminated that. Anyways, in the fifth module, it's purely on transaction and concurrency control, and some recent topic, and under that recent topic they introduced that NoSQL database. Okay, and transaction and concurrency control, schedule, serial schedule, non-serial schedule, how to serialize a schedule. Okay, so like that many points we will discuss here, and two-phase locking, log-based recovery, many things. Okay, and introduction to the no concepts, the recent trend NoSQL, the main characteristics, and something Redis, MongoDB, they are given as case study, and by looking at them we will understand this NoSQL databases. Now main characteristics of the something called column family database also. These are all again recent way of looking at this DBMS. Okay, so we will see that. And the textbook is the main textbook you are supposed to follow is LMS Sri Navate. Okay, so two authors are there. So you can either simply call it as the textbook by LMS Sri, or you can call it as a textbook by Navate. So I am much comfortable with Navate, so I'll be saying like Navate textbook. And so mostly I'll be referring this Navate textbook, and this syllabus charts and quote also I will refer. So anyway, you can so for the topics which I am covering, my PPTs and presentation will be enough for you, and for your own detailed reading you can refer the text. So the preference is like Navate is always, it's an easy to understand, but things are written you may like it's a big textbook and all, so you have to read and understand things. Okay, so what I am giving you is the is after reading I just concluded things, right? So that is what I am giving to you. So if you are directly reading into textbook, it will take time. So that's all. So if you are interested, you can go with the textbook and you can read and understand. Both are fine. But after watching my video, if you are reading textbook, it will be easy for you. So you will understand these are all the key points that I have to remember. You don't have to read it like a storybook. Okay. So that is the thing. So other references are also given, especially for this NoSQL concept and all, as they recently introduced them. Yeah. So we will see that. So that about it. Now the different possible questions from different COs and all it's given. On model question paper also given. We should basically I'll be keeping this as a reference, and accordingly I'll be teaching you the concept. Yeah, so here you can see a very big question, but it's simply about drawing a ER diagram, and it's a very easy to follow thing. But you have to go through the specification they are given, and accordingly you have to draw the diagram. So that's also, don't be afraid by seeing it. And here also some ER diagram is given, and you are supposed to answer a few questions based on it. This is from SQL queries. Okay, so like that the question paper may be looking like bigger, but concepts are very easy. Okay, provided you follow the things and you study the concept at the right time with the right pace. Yeah, that about it. Now let's see the introduction part. Okay, so maybe another 5 or 10 minutes I will take to cover the basic terminologies of this course. So the very first we can start with what is data, and then what is database. So data is basically a non-fact that can be recorded and that have a implicit meaning. So this is the definition I taken from Navate textbook. Slightly different interpretations may be there in different textbook also, but anyway it's simply if I'm saying that name of a person, his age or mobile number, or name of a place, whatever it is, randomly I'm just saying that. So these things, so we are dealing with the data, right? So every day we are dealing with huge amount of data. So if you are looking at the student database, you can see that name of all students, their address, their admission number. If I'm looking at each information as piece of information, I can call it as a data. So typically we will record it somewhere, right? So if you are looking at in your college, as staff advisor, I used to keep details of students. So what I'll be doing, I'll collect everything maybe in an Excel sheet somewhere. I will store everything, and maybe in Google Drive somewhere I will save that information. So typically data is something that is having some implicit meaning, okay, and that meaning is also, if I'm randomly saying that, say Arun, I know that it is name of a student in my class, okay, so but from a third party, like when you are here in the name, who is this Arun, there will be a number of questions in your mind, right? So meaning is actually implicit. If I add some more thing, then only you will get the correct meaning. Just your data as random, if I'm telling, you may not get the actual meaning. So but actually there is an implicit meaning that only the user who is familiar with the data can understand, something like that, okay. So and it is typically recorded somewhere. And now when the size of the data is very huge, we should need an efficient way of storing them in such a way that maybe the student details itself, suddenly if I want the details of a particular student, say maybe from Jammu and Kashmir or something, I should be able to retrieve those information quickly. So that is a requirement. So typically if the data I am supposed to have is small quantity, then I don't have to think about a concept like DBMS and all. Simply I can handle it using some Excel sheet, something, okay, in some manual way I can keep the information, and maybe in that I can do that searching and all, and I can find out the relevant information, what are all the things. So say I want to know how many students got that CGPA 10 or something, those things simply by looking at the Excel sheet I will be getting. But when the amount of data is huge, like if I am having one class student, it is enough for me, like some 70 80 students will be there, I can keep their data, and whenever somebody is asking me some queries like how many students are there in your class who scored that CGPA 10, I can, by simply manually I can find out, and I can reply to the higher authority. But instead of that 70 80 students, if I'm supposed to handle the information of the students of the whole college, maybe our college administrative people will be doing in your office and all, and that time it is more tedious, right? So from the whole college, if you're looking at all departments and all, and you want to find out all toppers or something, okay, so those who are coming under a particular category, like that, if those how many are from having fee waiver, like that, any information they can ask, okay, so for different purposes, right? So so simply we call them as queries. So different queries will come from the higher authority, and that time you may be in trouble, right? So because the data that are in your hand is not under your control, so it's huge, it's a large size data. So that time we have to look at some automatic means by which we can handle them in an efficient way, right? And there should be some computerized algorithms in such a way that they should retrieve the information in a fraction of seconds, because if we are doing it in manually, it will take hours and hours, right? So from some 1000 students data, or some 10,000 students data, if I want to get some information, it need time for me if I want to do it in manually. So manual way is there, but if our requirement is something a huge amount of data, we can go for the database concept, okay. So that about it. So examples are like consider the names, telephone numbers, or address, whatever it is, so some random data. So hope you get an idea about data, what is a data, okay. Now database is actually collection of related data. So there is a word related, okay. So typically if I am talking about some random set of data, I can't call them as database. So database, so collection of data, basically collection of data, okay. So database. And what kind of data? I don't want random collection of data, so I am talking about related data. There should be some relation, in the sense I can think about a database of students of CS department of CET, or so there is a relation, right? All students belongs to the CS department of College of Engineering, Trivandrum, or something like that. So there should be some relation. Randomly, if I am saying that details of some students, so which students, which college, in which state, like that, so that will go meaningless. So I don't want such meaningless random collection of data. The data should be related in some way. That relation is something defined by the organization. So what kind of organization it is, I'm just talking about a college, like examples I'm taking, but you can think about the employer details in a company, like say in IBM, how they are keeping details of the employers, right? So like that you can think about any example, okay. So there should be some relation, they are all working in IBM, maybe a particular research wing, like that, okay. A database models a real world organization. So see, this subject is very important because if this will make you apt for an industry, like industry mostly. So some web application development kind of jobs will be there, or something, maybe data analysis. So like that, in whatever it is, most of the fields somehow they are related to this database, because somehow we have to deal with the data, right? So that is what we are interested. So how we are organizing, and how efficiently we can take the data, how we can deal with the data, so everything matters. So a database models a real world organization. Example, it can be an enterprise or an university, etc. Okay, so basically some real world organization is there, and the data coming out from the organization we are modeling using the concept of database. Now if you change the organization structure somehow, okay, so maybe in the CS department on new stream is being introduced, right? So right now we are having this BTech in computer science. Suppose we are introducing that BTech in artificial intelligence, something like that. So accordingly the background database also you have to change. Okay, so whenever we are changing the organization structure, whenever you add new data, everything, the database keep on changing. So it's not something static. Database is dynamic in nature. Whenever there is a change in the real world, that change will be reflected in the database. Okay, now some examples of the database, if you are looking at something called a traditional database application. So this is where we apply the database initially. So they are basically dealing with the what I can say, some numeric numbers and text. So I can say like this. So the data coming out from this kind of application are just numbers and text. Okay, and there is nothing like images, videos, and also accordingly we have different database for handling them. So this is basically dealing with the numeric data and text data.